Okay, so I want to show you questions 8 and 9, and then I want to show you some problems on the board. So first of all, for questions 8 and 9, there is a difference between the x-axes. This one is with integers, and question 9 has multiples of pi. So that's going to have an impact on the period. What you want to do for starters is try to figure out where the asymptotes are. So I'm going to put yellow lines for where the asymptotes are here. This one has an asymptote at -1 and +1. Normally I would use dotted lines, but I'm just using yellow here, so you can still see that this is not the graph, but asymptote lines. Okay, so once you figure out where the asymptote lines are, then you can look at your function and decide, is this tangent or cotangent? And I can see from the orientation of this graph that is going to be a tangent graph. So for my answer, I'm going to write tangent. And next, I want to figure out the period of this graph. And since my graph is going from -1 to +1, that means that the period of this graph is 2, and if the period of the graph is 2, that means that the b value is going to be pi/2. I can also observe that this graph has not shifted to the right or the left, or up or down. That would make this a lot more challenging had it been shifted. And I'm pretty sure that this problem right here is not going to be shifted to the right or the left for you, so it should be simple enough to figure out what the period is. Okay, so the last thing I need to do is figure out what number might need to go out in front here, and I can figure that out by looking at the quarter cycles. So if I were to put a little notch here at a quarter cycle, and another notch here at a quarter cycle, and then follow the quarter cycle up, then I can see that this point is 2 and not 1. Likewise, down here I'm at -2. So the good thing here is that means that I have a stretch by the factor of 2. And here now I've added the correct answer from my open math to tangent pi/2 x, so you can see that. Alright, for the next one, we want to start in the same way by finding the asymptotes. So what we have here is an asymptote at, that looks like pi/2, and -pi/2. And that is your standard tangent graph. A standard tangent graph goes from -pi/2 to +pi/2, and you see that you have an orientation that is the same as a regular tangent graph. So what is interesting about this problem is not a change of period, but a vertical shift. So I'm just going to write tangent x, and now I'm going to observe that this graph has been shifted down 1 unit. And since it has been shifted down 1 unit, I need to have this -1 afterwards to represent the graph being shifted down 1 unit. And the only thing left I need to figure out is the number that goes in front here. We can look at the quarter cycles. Here's a quarter cycle. Follow this up, and I am at the point 3. However, that is not a stretch by a factor of 3, because 3 is actually 4 above -1, right? So if you look at this quarter cycle over here, you don't see -3, you see -5. Why? -5 is 4 below the center. The center is occurring at -1. So we have 4 above and 4 below, and that confirms to us that the stretch is 4. And now we can check the answer here. for tangent x minus 1. So putting the parentheses here is actually a nice thing to do, just to really clarify that the negative 1 is not included in the parentheses, although it's not required. So next what we're going to do is we're going to go to the board for some board work. It might actually help for you to graph by hand before you do your MyOpen Math problems. It might give you a better understanding of the cotangent and tangent graph. So what I want to observe first of all is that this cotangent graph does not have any horizontal shift, and it does not have any vertical shift, which is nice. I'm only looking at a horizontal stretch and a vertical stretch. So cotangent has a period by default of pi. In this case, because the b value is 2, the period then is going to be pi divided by 2. So since I have no horizontal stretch, the pi halves increments will be the asymptotes for this graph. And the instructions say here to graph on a 1 period interval, so that means that my graph will be pretty simple. One of the asymptotes is the y-axis, and then the other asymptote is going to be at pi halves. And this will give me 1 period of cotangent. So of course now we need to add the quarter cycles, and a quarter of a half is an eighth. So that means that each of these quarter cycle marks will be 1/8 of pi. So we have pi eighths, 2 pi eighths, or pi fourths, and 3 pi eighths. And then, of course, 4 pi eighths is pi halves. So next, I want to pay attention to the fact that the orientation of this graph has flipped upside down. So usually you would see cotangent going in this direction right here, the negative direction of tangent. However, with the negative here, we're actually going to flip the cotangent over. So now it's going to take tangent's orientation. Another thing that we're going to observe is that there is a stretch, or really a shrink. It's going to become 1/2. So that means that for my vertical axis, I need a 1/2 and a negative 1/2. So now you can just plot the points. I know I'm at 0 right here in the middle. Since my orientation is now going to be like tangent, I have a point at 3 pi eighths 1/2 and at pi eighths negative 1/2. And that is the graph for number 24. So for number 26, we do not have any sort of vertical stretch. We do not have a period change. No, we do have a period change, but we do not have a vertical stretch. So what we're looking at is or vertical shift. What we're looking at is a horizontal shift and a period change. So we want to look at those together. So the first thing you would want to do is you would want to factor out the b value. And by doing that, by factoring out the 1/2 here, I can then make the observation that the period of this will be 2 pi. Because pi divided by 1/2 is 2 pi. Now, what's really handy about that is that the horizontal shift is to the left 2 pi. And remember from a previous lecture, I said that when our horizontal shift is a multiple of the period, you can't even see it. All you're doing is shifting that wallpaper over to be on top of a previous pattern, which is identical. And so you're not going to notice any difference at all, which means that we can just graph this as y equals tangent of 1/2 x, and it's going to be an identical graph. We only have to do, actually here we're doing 2 period intervals. So for a 2 period interval, knowing that we have a period of 2 pi, that's going to span a total of 4 pi. Now tangent straddles the y-axis, so what I would want to do here is have part of the graph to the left, so this will be negative pi. Here's positive pi, 2 pi, and 3 pi. And then by putting the asymptotes here at negative pi and positive pi, that would give me 1 period. And then from pi to 3 pi, then I have a second period. For quarter cycles, 1/4 of 2 is 1/2. So that means my quarter cycles are at multiples of pi halves. And then lastly, tangent has an orientation like x cubed. So I'm going to have my graph go up. There is no vertical shift, no vertical stretch. So my axis would have a 1 and a negative 1. I have one point at pi halves 1, another one at negative pi halves, negative 1. So there's my first copy of tangent. And then over here, so now to explain again what happened with the with the horizontal shift, the horizontal shift is 2 pi to the left. So if I took this graph right here and I moved it 2 pi to the left, this is what it would look like. So by taking this copy and moving it to the left, I end up with the identical copy. And there are an infinite number of copies to the right and an infinite number of copies to the left. So if you shifted over any multiple of the period, you can't even see any change on the graph. Okay, next problem. So now flipping the page and going to page 172, number 34, you can rewrite this as y equals 1/2 tangent x plus 3. Make the observation that you have a vertical shift up 3. You have a vertical stretch, well, it would be a shrink, by a factor of 1/2. There is no change to the period and there is no horizontal shift, which means that we're going to have negative pi halves and positive pi halves as the default here. So let's go ahead and put those horizontal markings into place. Actually, I would like to have a lower x-axis because this is shifted up, right? So here I'm going to have negative pi halves to positive pi halves. This is the default period for tangent. From negative pi halves to positive pi halves, tangent will straddle the y-axis with half of it to the right, half of it to the left. That's a period of pi. Then we come again over here to pi and then to 3 pi halves, and now we have another copy of the graph. So pay attention to the number of periods required in the directions. For quarter cycles, a quarter of a pi is 1/4 pi. So here we have negative pi fourths and positive pi fourths, 3 pi fourths, and 5 pi fourths. So here are the horizontal markings. It's the default tangent. Everything that's happening to this graph is happening up and down, not side to side. So what we want to do is have markings in increments of 1/2 on the y-axis because I have a shrink by a factor of 1/2 here. So 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So the center of this graph is going to occur 3 up. So I go 3 up. I have a 0 point, so to speak, up here at +3 for both graphs. Okay, now with a factor of 1/2 as your stretch, that means that your quarter cycle is going to be 1/2 above your 0 and 1/2 below your 0. Your 0, of course, in this case is 3, so you have 3.5 and 2.5. Same over here, 3.5 and 2.5. Either use graph paper or line paper, so your graphs are going to look better than this. And then make sure that you have a curvy graph. Make sure also that in addition to the graph being curvy, that your graph never crosses an asymptote. So right there is sufficient. You do not need to have the graph come all the way down and cross the x-axis. You just need to make sure that these points are clearly shown lining up with your x-axis marks. Okay, last problem. Now what I've written on the board for number 36 is not what it says in the book. In the book, the -2 was out in front. I just took the liberty that when I copied it down, I shifted it around using the commutative property of addition and put the -2 at the end where I like it. Secondly, I went ahead and factored out the b value so I could skip straight to the graphing. So you can note the changes that I made by looking at page 172 and seeing the original problem provided and seeing how I changed the function by flipping it around and going ahead and factoring out this b value. So what I can do then is try to figure out my period, which is going to be pi divided by the b value. So very nicely again, I happen to be in a situation where the shift is actually going to match up with the period, so I can ignore the period change. My graph will be the same as 3 tangent 4x minus 2. Still, I have 3 things going on here. I have a vertical stretch, I have a horizontal shrink, which is a period change, and I have a vertical shift. So at least I don't have all 4 going on at the same time, but I have 3 out of 4. So what I want to pay attention to, first of all, is what kind of markings I would need on the x-axis. And when I draw my x-axis, I'm going to be noting the fact that this whole graph is shifting down too, so my x-axis will be up high. So since the period is pi fourths and tangent straddles pi fourths to the right and to the left, half of a period would be -pi8, and to the right, +pi8. Together, -pi8 and +pi8 form a distance of pi fourths. So that would be the first period for my graph. And then over here, you're going to have 3pi8 for your next asymptote. And 1/4 of 1/4 is 1/16, so the quarter cycles are at pi16. This is -pi16, positive pi16, 3pi16, 4pi16, which is pi fourths, and 5pi16. Again, just multiply 1/4 times the period, and that would give you your increments for quarter cycles. Okay, so what you might find helpful, and I should have done this on the previous problem because that would have been helpful, is that when you have a vertical shift, you can draw a horizontal dotted line. My horizontal dotted line is going to be at -2. And by drawing this horizontal dotted line at -2, I'm going to have my graph be kind of at a 0 here at -2 because the whole graph is just shifted down 2. So now what I need to do is I want to have a 0 dot at -2 halfway through each of these cycles, and then this is a stretch by 3. So when I come a quarter cycle over, I need to go 3 up, and a quarter cycle back, I need to go 3 down, and that's why I went all the way down to -5 in the first place. This graph stretches between, hold on, be very careful about where you're crossing the axis here. I need to cross before the axis, cross the x-axis before I reach this notch, because otherwise I will be failing the vertical line test and this won't be a function. So be cautious about that. Likewise, over here, I'll have a dot at 1 and then another dot down here at -5. Going to the left is easy. Going to the right, you want to cross the x-axis before the 5π/16 mark, and there you go. So that is our tangent and cotangent lecture for today, part 2.